Okay, so what is scientific notation? Scientific notation is a way that we can write numbers that are really, really big or really, really small. Especially, you guys have probably seen in your calculators, sometimes you type something in that's too big for the calculator to give you the answer, or too small for it to give you the answer. And so, what it'll do is it'll give you your answer in scientific notation. Scientific notation has two parts to it. One element is a power of 10. And the power of 10 basically tells us where the decimal is supposed to go. The other portion is any number that's between 1 and 10, meaning there will be one digit in front of the decimal place, and that digit can't be a 0. And then it'll have any number of digits after the decimal place. Standard form, because you're going to hear me using that term, is the way a number is typically written. So in this example, we see that Saturn has a diameter of about 1.2 times 10 to the 5th kilometers. This is in scientific notation. So I'm going to put SN for scientific notation. Its distance from the sun is about 1,427,000,000,000 kilometers. And this is written in standard form. So I'm going to put SF for standard form. So you can see having to work with a number this big can be really tricky. So in order for us to convert back and forth, we just need to focus on the decimal places. In this video, I'm going to go over how to write something that's in standard form into scientific notation. So we need one that's in standard form. This one is in standard form. And we need to first figure out where would the decimal need to go so that I only have one digit in front of the decimal. In this case, it would go there. And then the only other thing we do is we have to count how many times we would have to move the decimal to get it there. Now keep in mind, if a number doesn't have a decimal place, its decimal is at the very end. So in this case, it already did it for us. It counted out. We would need to move the decimal 9 places. That number, the number of times we had to move the decimal, is the exponent for our power of 10. It'll be a positive number if we had a big number, and it'll be a negative exponent if we had a decimal. So let's look at some more examples. I'm going to look at numbers that are only in standard form. So I'm going to look at number 9, number 11, number 12, number 15, number 17. All the other ones are in scientific notation. So we're just going to focus on these first. In number 9, remember there's no decimal, which means it's secretly at the back. So where do I need my decimal to go? Well, remember, we can only have one digit in front of the decimal place. So I'm going to put my decimal between 1 and 3. And to get it there, I need to move the decimal 1 time, 2 times, 3 times, 4 times, 5 times, 6 times. That number is going to be my exponent on the power of 10. Once we rewrite it in scientific notation, we only need to write down the digits that aren't 0. So I'm going to write down 1.34. I don't have to write down all these zeros, times 10 to the 6th power. Now, what do we do if it's a decimal? It works a similar way. I still need one digit in front of the decimal, which means I'm going to need my decimal to move between these two 7s. In order for that to happen, I need to move it 1 time, 2 times, 3 times, 4 times. Now notice before we were going to the left. Now we're going to the right. We had a decimal. So I'm going to write out 7.75 times 10. But this time, instead of a positive 4, it's going to be a negative 4. And that negative tells us that it was a decimal. Go ahead and do the other examples, and I'll meet back up with you.